First off, thank you for coming out tonight. We've been hosting meetups over the last several months in and around Boston. Typically we have CTOs, CEOs of companies in the area that are leveraging machine learning. We've had companies doing cool things like airport security, where they shoot radio waves at you and try to figure out if you're holding some sort of hostile device or compound, chemical compound. We've had CEOs from companies that have investments from Bill Gates, Mark Cuban, and just really a lot of promising companies in the area. And we hope to continue to have meetups. We're still kind of ironing out kind of the venues and the accommodations and things like that, but it's been super nice to have WeWork host this event here. And also, when I was out in California the last 2 months, they were super accommodating there as well. So it's really awesome that they helped us out with that. So the talk tonight is it's kind of ambitious, kind of bold. It's how to monetize machine learning algorithms. And kind of where I came up with this idea is I've been going to meetups for the last several years, and time and time again I hear a lot of kind of like machine learning kind of researchers and specialists, and they're doing a lot of really cool things, but I look into the audience and their eyes tend to glaze over a lot of the times, and I can just tell that they're not tracking along with a lot of it. And it's super useful, and it's awesome to see people moving forward kind of the state of the art when it comes to this stuff. But kind of my interest is how do we get it into the hands of consumers? How do we actually leverage this to create an ROI for businesses, to create better consumer products for end users? So that's kind of how, kind of my interest when it comes to this stuff. I work for an enterprise A/B testing platform. We service Fortune 1000 companies, so I've just been able to see scaled out web applications, how they work. I push code to really big websites. Typically it's retail sites, but we've also done insurance, we've done banks, hotel accommodations, a lot of retailers, Urban Outfitters, Ann Taylor, companies like that. And so I'm kind of able to see how these companies are trying to use these things to create an ROI in their web applications. And the way we've structured kind of our value proposition to these companies is these companies get pitched by smart founders and small companies all the time that say, hey, we have this really clever machine learning algorithm, and if you just implement it on your website, we'll increase your conversions like 10%. And these companies, they don't know. They're either a fashion retailer, or it's not their core center. Their core strength is not this technology stuff. They're not on the cutting edge of technology. And so what we do is we say, okay, we'll push it out as an A/B test, and you can show us exactly how you're gonna increase conversion or whatever KPI these companies are concerned with. And it's a really good model because they can do these 90-day proof of concepts, and these vendors can really prove themselves. And we can even do head-to-head, two vendors vying for the same position on a site. Just some examples of things we do, like recommendation engines. Like you come to these sites, these companies don't own recommendation engines. They've outsourced that to a third party who specializes in that, and those engines are pretty sophisticated at this point. We've implemented a whole host of tools on those websites. I'm a Docker captain. That's what they call it. It essentially means I've done training. I've done Docker training at events and kind of help facilitate their onboarding with people interested in Docker. Just quick note: if you're into web technology, if you're into machine learning, Docker is really a good investment to learn, and it'll save you time in the long run. I've also done training at major financial institutions. Vanguard is one of our clients. One of the tools that I recently implemented is a tool called Gratify. I did the deployment for a major retailer, and essentially what they do is we track a user's behavior on the website. We track the way they interact with products, the way they view images, the way they traverse the site, the way they add items to cart, etc. And we send that back to Gratify, and Gratify comes up with a machine learning model. And that model is used to predict the propensity of a user to convert. And really, we're trying to figure out, are they on the fence in terms of converting, or are they just kind of browsing? And if they are on the fence, what can we do to knock them off? And we do certain things, kind of clever little things, incentivized messaging, social proof, limited inventory, just kind of little things that don't cost money, that we're able to, instead of just barraging every user, we're able to kind of like target a subset of users who are actually going to be affected and influenced by that messaging. And we rolled this out as an A/B test, and we were able to determine a significant increase in conversion. And they actually were able to oust a competitor, which was a really cool thing to do. So I have been able to implement some of these machine learning models in real applications and actually generate an ROI from that. But just one note is like, yeah, these companies, they're not doing it in-house so much. They're kind of outsourcing it to vendors who specialize in that. And these are just a whole host of other tools that I've implemented on different websites. Things like Trufit is kind of an interesting concept of how to keep your size consistent across websites when it comes to retailers. Rich relevance recommendation engines, reflection recommendation engines. This app down here is super interesting, kind of like a precursor to VR. They literally scan the garments, and you select a body size, and you can literally watch how the garment will fall onto a particular model, and uses a little bit of machine learning, but more kind of like this VR concept. And the idea is like, how do we get rid of how do we create like a virtual changing room essentially? But these are just all kind of vendors that, you know, they sell to retailers, and I've been able to implement them on a lot of our clients. So as far as this talk goes, you know, the title, how to monetize machine learning algorithms, there's a couple different ways to do it from what I've been able to see. Consulting is a big thing. You're a company, and you specialize in machine learning, and companies come to you with kind of a problem that they want you to tackle, and you kind of do this whole project management cycle where you come up with a model, hopefully it does what they want, and then you deliver it at some time, and they pay you for that. And that a lot of companies around Boston are doing that. I don't know, kind of one of the drawbacks of that, I would say, is you don't really get to pick what you're working on. So if you're interested in a particular like field or something, you know, you're kind of you're subject to whatever your clients want you to apply this technology towards. Another option is you can build a company that does that particular thing that you've solved with machine learning. So Gratify, they've solved user tracking, user behavior prediction, and things like that, and they just built a company around that, and that's what they're going to do for the next 10 years, as far as I can tell. So that, you know, that's one concept. You come up with a really nifty machine learning algorithm, you just build a company that does that. What I don't like about that is, you know, you can be the hot new thing for a while, but then other companies can come in and offer that same thing, and suddenly there's a lot more supply there and a lot more competition, and it can happen very quickly. So what I want to explore tonight is another alternative, which is creating a model and publishing it on a marketplace, and then just doing a profit share with that marketplace. This is kind of like the newest approach, but I feel like this is going to be probably the most common way that machine learning is going to find its way into applications in the future. And what's really cool about that is you can create a model, you can publish it, you can market it, sell it as much as you see fit. And if you get bored with it, you can take it down, you can maintain it, or you can move on to onto another model that you might think is more lucrative, or whatever whatever avenue you want to pursue, you can do with this. So there's a bunch of different marketplaces out there that kind of facilitate this whole process. I'm sure Google and Amazon will be getting into this space. But there's a couple different ways you can do it, and I created a tool that can help you do this, and that's what I'm going to show tonight. But what we're going to do is, really the tool is incidental, it's interchangeable, you can use a bunch of different tools. We're going to create a machine learning model tonight that does something cool, I think, and then we're going to publish that to a platform where other people can use it, and other people can pay money to have access to that, and you would be able to actually make money with that. We're going to use TensorFlow. We're going to use TensorFlow with Docker. We're going to do an image classification model, which is computer vision, and hopefully we can kind of do it together. And I'm going to kind of walk you through that whole demo, and hopefully by the end of this, you guys will feel comfortable being able to do something like this yourselves. Just quick disclaimer, I'm not like machine learning researcher. Like I'm not really low level like algorithm optimization. I have a high level grasp of it, and I'm interested in machine learning to the extent that it can be used like by real people. If some guy comes up with a really cool model that can predict the future, but no one ever uses it, like what good is it, in my opinion? So I'm kind of more concerned with like how these things are going to actually be deployed to end users. And just to go over at a high level how this works is, you come up with a model that you think is commercially viable or whatever, and you can upload it to a platform, and it'll be exposed as an API. Whoever's going to consume that model, whoever's going to use that model, it doesn't really discriminate. It could be a web application, but it could also be like an IoT device. It could literally be anything. Like you could have a drone that has its intelligence in a remote API, or an Alexa, Echo, whatever, that is getting its intelligence from some sort of remote API. This is it would be like a low-level sort of intelligence for some sort of end user consumer product. So we will get started on going through that demo. Just to reiterate, we're gonna build an algorithm. We're going to publish it to a marketplace. We're going to tag it, price it, market it, and then I can demo it for you guys. And I think just the aspects of building the model itself should be pretty useful for you guys, since we're going to be using TensorFlow, we're going to be using Docker, we're going to be using an API marketplace. So I think all that stuff will be useful for you guys. So just real quick, who has created an actual machine learning algorithm before? Okay, cool. And of you guys, did that algorithm, was it kind of nuanced, or did it have some sort of like utility outside your project, potentially? Was that yes? Okay. Others?
Algorithm or model?
Algorithm.
Sure, yeah.
Okay. All right. So you guys are both, you qualify as potentially having something that someone else could use. You could publish to a platform and could be used by a third party. So that's cool. All right. Cool. Let's get started with this. So just raise your hand if you are familiar with Docker. Okay. Cool. So Docker essentially is a way to run VMs. It's super easy. What's nice about it is you don't have to download all kind of like the dependencies. So for instance, we're going to be doing our development with TensorFlow, and instead of me having to download the million dependencies for that, I can just run everything out of a Docker TensorFlow container. So that's exactly what I'm going to do. So the first thing we're going to do is we're going to grab the the TensorFlow Docker container, and that's exactly what this command is going to do here. So this is hosted on the Google. The Google remote registry. Docker Hub is the other big one, and you can have private registries as well. So our system works with Docker Hub, but eventually we're going to move it over to Google. So I actually just downloaded the Docker container that has all the TensorFlow dependencies. It was super quick because I actually already have that stored locally. So I'm just going to run just real quick so I can see what I have going on here. I'm going to run Docker images, which just lists all the images that I have here. So I already have it. That's why it was super quick. I'm going to run Docker list for containers, and this just shows me what containers I have standing up. So I just when I downloaded this container, I also threw in this this D flag, which is called detach. So I stood up a container. I downloaded the image and I stood up a container, and you can see here in our container list command, this container has been up 37 seconds. So what I can do is I have that VM running now. I can log into that VM and do all my TensorFlow development, and that's exactly what I'm going to do. So I'm just going to do docker exec -it, which just logs me into this container. I'm going to pass it the container ID, and then I'm just going to run bash. So it creates a shell in the container. So if I go to root directory, it might look familiar. It's either Ubuntu or CentOS. I'm not 100% sure. But it's got all the dependencies. So you can see it has this TensorFlow directory, and it also has that run Jupyter.shell. That is the Jupyter notebook. So a lot of the times when you're doing your development, you're probably not going to do it via command line. You're probably going to do it in the Jupyter notebook. But okay, so we have a VM that we can do our development in. It has all TensorFlow dependencies. I said I'm going to do an image classifier. So I kind of did a demo where we created an algorithm that could classify a couple objects in an image. One object I want to definitely do is pens. I want it to be able to detect a pen, but we need more categories. So does anyone have a suggestion that we can create to detect an object, something in this room preferably, maybe a cup, a chair, a laptop? Be creative. Chair.
USB cable.
What was it?
USB cable.
Do we have a USB cable in this room? I think we do. Yeah, I like that idea. Cool. USB cable. A little bit more authentic there. All right. So this is what we have to do. We have to download a bunch of images of USB cables. We have to download some images of pens, which is the other thing I want to do. And we could do more, but I think it's just going to slow us down. So we're going to create a model that we can run an image against, and it's going to try to determine if it's a USB cable or if it's a pen. And you could create, a third tier, like as a catch-all. We're not going to do that right now. We're just going to come up with a kind of probability for each one. So we're going to kind of piggyback on some work that Google did. So there's this model called Inception, which is an image classifier. It comes pre-trained in this TensorFlow Docker container. And what we're going to do is something called transfer learning, where kind of all the heavy lifting had been done previously, and we're going to just train the final layer. And it allows it to be a lot quicker, and it's actually very accurate. So what we're doing, although it's a quicker way to do it, there's nothing it's a valid approach, definitely a valid approach. So it's a CNN, convolutional neural network, that takes in an image and then gives back probabilities for the labels that you supply. So let's grab some images of some pens. Getting data can always be difficult, and I've kind of come up with some like hacky ways to do it. Basically, I'm going to pull a bunch of images from Google search, and I'm going to use that as our training data. So if we just search for like pens, come over to images, there's this nifty plugin, and I'm sure it's not sanctioned by Google, but we're going to use it anyway, that allows us to kind of scrape all these images. So I'm just going to click select, and I can add the name of this plugin. I think it's just called Batch Image Download. It's a Chrome extension, so you guys should be able to find it. And I'm just going to add a little filter here, because what it's doing is it's grabbing every image on the page. So like for instance, these are logos. We don't want to use these. That would throw off the model. But let me just audit this list real quick. So these all look good. These are pens. I'm just going to go down here. Okay, everything looks good for the most part. Does anyone see anything that shouldn't be there? This down here, right? Alright, so we're just going to download these images. And again, this is not an exhaustive list. Like, you would probably want to be a lot more thorough, but I think it's actually going to work just fine. So using this Chrome extension, I'm going to create a folder. I'm going to call it demo-pens. And we're going to download this data into our folder. And like I said, it's a little hacky. I wasn't kidding. So this might just take a couple minutes, but it should be fine. It's probably 100 images, I would say, around roughly. So it just has to queue them all up here. I'm going to keep up with it right here. Should not take long. Let's see, come on. All right, it's going to download all these. It's going to download all these images into a local directory. We're going to have to throw that. We're going to have to copy that directory into our Docker container, but that's not hard to do. So let's just keep going through here. All right, still going. Should let up pretty soon. All right, come on. Let's see.
While it's downloading, what was the Google pre-work library that you're making use of?
The what?
You're making use of Google's image recognition.
Yeah, it's called Inception, and they did kind of like a whole thorough write-up about it. And basically, they put that into the TensorFlow directory, and they kind of set you up so that you could train that last layer, which is what we're going to do. All right, so we just downloaded all those images. What was the other one? USB cables? All right, let's do that. So this looks good. Our connection should be decent. All right, come on. Oh, no. We're going to wait because we're kind of doing some heavy lifting here. Sometimes you gotta give it a second. Chrome's pretty good. Let's see. Alright, so I'm just curious. I'm gonna check if those have downloaded. So let's go over to my downloads. Okay. Alright, so that is the name of the company that has the extension, so I'm just going to go into that file there. That folder. Alright, so this browser is slowing us down a little here. Alright, let's try. It should be a Chrome Task Manager. Oh, wait. Yeah, it's just having trouble loading right there. Okay, I think we might be good. Let's see here. So let's see if our image is downloaded. Yeah, again, the name of the company is like Weixia, so navigating into that folder. Should be a folder called Demo Pens. Alright, so they throw it in this new subdirectory, which is kind of annoying, but cool. We got a bunch of images of pens. Cool. Let's do USB cables. USB cables vary quite a bit, so hopefully we don't... I think it'll work. All right, cool. So same deal. We're just going to download a bunch of images. Getting images is actually harder than I thought. I've played around with like the Flickr API and stuff, and they really don't want you to take their images. All right, so we're going to dig these images. We're going to select all these images. Let's get rid of the ones that we don't want. Okay. All right, looks good. Looks good. Looks good. All right, that more or less looks good to me. All right, so what was that?
There's a blank port.
There's one in there. Thank you, though. All right, cool. Let's download these. So create new site folder, demo-USB. Hopefully it doesn't blow up this time. Should be all right. Just give it a little time. All right.
Kudos to you for doing it live.
Well, what's cool about this model is like you don't have to do a lot of pre-processing. Like I don't even know the dimensions of these images, and it takes care of that. So pre-processing your data and getting it into like a consumable format can be difficult. So it's kind of cool that we don't have to kind of abstract that away. All right, this should be letting up soon. Come on. There we go. All right, all right. Okay, so again, we're just downloading a bunch of images of USB cables as per the request. And we should be creating a classifier that can determine relatively accurately what's in an image, whether it's containing one of these objects. So I just don't want Chrome to freeze here, so I'm just going to give it 1 second here. All right, let's check out locally and let's see what's going on here. So there should be a folder called Demo USB. There is. And there should be our images in there. All right, cool. All right. Okay, so this .cr download means they're still being downloaded. So let's give it 1 second. All right. So while that's happening, let's create some stuff locally for our development. So again, I'm just in my Docker container. Docker container is just an Ubuntu VM that has all our dependencies to do our TensorFlow development already set up. So we don't have to worry about any of that stuff. I'm going to create a directory called tf_files where we can put these images and keep them all in one directory. So I'm just going to do make directory. Just the download is bogging down the system a little bit, but it should be all right. Yeah, so we'll create a directory, we'll throw all our images in there, and then we'll train the model on the images, and we should be able to run a couple predictions to see how good it's working. Let's see here. All right, cool. So we're going to make our directory called tf_files, TensorFlow files. You can see it is there. That's awesome. Let's see here. Okay, cool. So our files should have finished downloading. So these .cr downloads should now just have a typical file extension. Cool. They do. Sounds good. All right, let's move both of these subdirectories over into our Docker container. Now, technically it's a VM, so getting assets from one to another can be difficult. You can do it with networking. We're not going to do that. There's a native Docker command called cp, copy, and it lets us copy a local asset directly into our VM. So that's what we're going to leverage here. So it's pretty straightforward. Let's just navigate up. What was that?
Can you clean up some log and delete stuff?
You can, but that's more overhead than doing it just this way. I'm just going to rename this directory. It says 2408. This is the USB directory, so let's just change that to a more descriptive name. So let's call that the just USB. And then we're going to just copy this over into our container. I forget the ID, so I'm going to do list containers. We're going to do docker cp USB. We're going to pass it our standing container. And then we're going to throw a colon there. And then we want to copy it right into tf_files, I believe. All right, so that should have just copied the whole USB image directory into our Docker container, into this directory here. Cool, we can see it there. Let's just double check. Looks good. Let's do the same thing with the pens. So let's navigate up one. Let's go into demo pens. Oops. Demo pens. Same deal. Let's rename this because that's not descriptive. We'll call it pens. We're going to do it should be in here. Docker cp. Instead of USB, let's do pens. That VM. Not pretty trivial, not hard. And then let's just verify that it's there. Should have copied into TF files. Okay, cool. So in our VM now we have our training data, our images. It's in a directory called TF files. Okay, so let me think what's next here. I think what we want to do now is run the actual training. This container, this Docker container, gives us the actual script that will do the training, and we just have to supply some arguments. One of those arguments is going to be the directory for our images, so it knows where to get those images. The actual file that they supply you is called Retrain, and it's in the subdirectory here. So they give you a lot of utilities in this container. So if we actually go into the TensorFlow, I just want to show you guys kind of the stuff that they give you. So they give you a bunch of examples. Cool. Look at all these types of examples that they give you. Benchmarking, image retraining, multi-box detector speech commands, Udacity, wave to spectrogram tutorials. They just give you all this stuff to work with. And we're going to leverage image retraining. So this is where the Inception is. And then they give you these scripts. One is, these are written in Python. Retrain.py is what I said. It's going to retrain the network on our images. Label_image is the predicting script. So that's the script that you feed a novel image to, and it's going to run your retrained model against. So hopefully that makes sense to you guys. And hopefully I'm not losing too many people. I think I'm trying to keep it high level. So let's run the actual training here. So again, I'm in my Docker container, and we're actually going to run the training. So there's several arguments. It's kind of verbose. I get it. I had to copy and paste this. You can find this little snippet all over the internet. So you can kind of just copy and paste it. Bottlenecks, that's boilerplate. Model directory, boilerplate. Output labels. Yeah, we'll keep that the same. Yeah, the only thing that we're supplying that's unique here is we're supplying the parent subdirectory where our images are going to be stored. So when this script runs, it's going to go into tf_files, and it's going to create a label out of the name. So it's going to see pens. It's going to go into pens. It's going to grab all those images. It's going to create that into a label, which is fine. It's going to do the same thing for USB. So we're good on that front. So let's actually run the script. There's some other additional parameters, like how many steps you want to do and all these other things that we're not going to worry about right now. It should train pretty quickly because our data set is really small. So let's try this. Let me just double check this is good. Again, this is a Python implementation here. I think this is okay.
What method do you use?
What was that?
Which algorithm?
Which what?
You don't know?
Which algorithm?
Yeah.
For the Inception, I mean, it's a CNN. CNN, I would imagine there's several. I'm not exactly sure what the underlying algorithm is for this. If you Google the Inception, it should tell you.
It's a convolutional neural network.
Yes, it's CNN. Yeah, that's right.
But did you choose it or?
No, I didn't. So what we're doing is, for us to build this from scratch, like if we were to actually select like what layers it's going to use and then pre-process the data, like it's going to take a lot of effort. And we can bypass all that by using a very reliable image classifier that Google's created, and they set you up so that you can just train the last layer, and it's incredibly accurate. So a lot of the heavy lifting has already been done, and we're just going to retrain that last layer on the images that we're supplying. So it allows us to quickly, rapidly create image classifier.
Last layer, you mean the last layer of the neural network?
Yes.
So you do it transfer the...
Yes, exactly. Yeah. Not the only way to do it, but for the sake of a demo, is the only way I could figure out to do this quickly. But they've done so many write-ups on Inception, so I would definitely check those out. So it's downloading this file right now, and then it's going to run the training. It shouldn't take too long. Again, we don't have a lot of data. But what we'll do that's interesting is I wanna end up feeding it some data that it's never seen before, some images that I take. So that's why I kind of wanted some objects in the room. So I'm going to take a picture of this cable right here, and we're going to feed it into our network, and we're going to see how accurate it is. So that's what I'm going to do right now. This cable is pretty standard, so it should be a non-issue. So we did a cable, and then we did a pen. I have a pen. Let's see here. Alright, I have my courtesy of WeWork pen. Alright, cool. So it downloaded what it needed, and it's going to run the training right now. So it's setting up the labels. So that's cool. So wood on wood, I wonder if that's going to be an issue. Probably not. Alright, so.
Which file did you download?
I didn't download anything. I'm just running the retraining. It's just doing the retraining right now.
Downloaded the actual Inception model.
And it only does that once. Like when I retrain again, it won't do that again. Because this Docker container is new. Alright, so I'm going to shoot these images onto my computer so we have them while it's doing the training. Okay, so I just got to turn on Bluetooth. I'm going to do AirDrop. Come on. Oops. Alright, why don't we do this? Okay, I'm just going to email these to myself. AirDrop not picking up, but it's still training, so it should be fine. Alright. Okay. Let's see here. Cool.
That could have been anything.
What was that?
That could have been anything.
I know. I'm just. How do you get this to? That's peculiar. Spark's not helping me out right now. Any ideas on how to download this?
Yeah, right click.
I'm trying that. It doesn't seem.
Maybe open it up.
So I think that is open. Alright. You know what we're going to do?
Screenshot?
I guess.
Oh.
Except, alright. That's kind of whatever.
Innovation.
Not optimal, but whatever. Okay, cool. Got our pictures. Hopefully those dimensions aren't problematic. I don't think they will be. Alright. Let me grab those images, and while we're waiting for that, we can throw it into the container there. So those should go to my desktop. I think so. Let's see. CD users.
So it doesn't go into its own folder?
The screenshots?
Yeah.
The screenshots are just hanging out on my desktop.
No, I meant when you go to validate.
No. So we're gonna one of the arguments for the validation, the prediction, is a reference to an image. So we're just gonna feed it an image. I just don't know the names of these, so let's just double check. Okay, this is pen. So let's call that pen. Cool. We got pen. Let's call this USB. Of course, doesn't give me the error that time. You know what? We're going to do it the hard way. Alright, so USB.jpg. Cool. Alright, so there are our images. We're going to do the same thing. We're going to copy those into our Docker container. So let's just do docker cp pen. Let's pass it the container ID. Container ID, and then let's do the same thing with the USB. Alright, so those should be copied into our Docker container. Can't really tell yet because our thing is still running. So actually, we can check. Let's log into our Docker container from another terminal. Cool. So let's go to root. Alright, cool. We got pen.jpg, usb.jpg. The model is going. It shouldn't take much longer. It usually takes like 5 minutes. Let's see here. Wasn't that much data. Let's see what else. While I'm at it, I'm going to need a text editor, so I just want to install Vim real quick. You guys know Vim, text editor? Yeah. Because at the very end we're going to create a script to kind of piece it all together. And Vim doesn't come pre-installed on Ubuntu, so I'm going to download that real quick. Then we should be on our way. Glossing over a lot of details, I get that. Just trying to get to the end of it within the time.
That makes sense.
Cool. All right, so this was just to update packages because I'm going to get the Vim package in 1 second. So Vim, so I can edit a file. All right, so apt get install. All right, so now I can edit a file. Yeah, looking good. Famous last words. All right. So I'm just finishing up downloading Vim so I can edit a file. And I got 2 terminals running in our Docker container. You can see it says root at Docker container. That's the ID. All right, model should be trained. Model should be trained. Let's take a look at, so it wrote these two files. It wrote retrainedgraph.pb and it also wrote retrainlabels.txt. It pulled the labels from the name of the folder. So I'm just going to look at that file and verify that it is looking good. Cool, it got pens and USB. Those are our two labels. So we're going to feed it an image and it's going to come up with a probability. It's going to pick one or the other. So the percentages will add up to 100. You probably would want to have a catch-all if you were trying to do like a classifier that just looks for one image, but for the sake of the demo, I thought it'd be cool to have multiple categories here. Alright, so our next thing that we want to do here is we want to run a test. We want to run a prediction on a novel image. So hopefully this should work. So they gave us retrain.py to do the retraining. Well, they gave us label.image to do a prediction. I would have renamed this like prediction.py or predict.py. But anyways, so that's the utility that's going to pull these two files, the retraingraph.pb and the retrainlabels.txt, and it's gonna run the new data against the model that we just trained. So again, Python script, several arguments. The two arguments that we can just keep are what it just created, and then what's new is this reference to an image. So let's feed it pen, which is the WeWork pen that I just showed you guys. And hopefully this works.
Nice.
Looks good. Alright, now the USB, which I'm not as sure about. So I'm running the same script, but I'm passing it that USB image that I just took and emailed to myself. Not bad. Pretty good. Okay, cool. So we have a model that's pretty accurate. 97, not bad. USBs, like I said, they have quite a variance. But pens, 0.998. That's pretty good. Okay, so cool. You come up with a model, and this isn't a rocket surgery model, but imagine you have a model that does something like really cool. It doesn't even have to be super cool, but something that's not out there already. That's when you would want to push it to a marketplace. So like, I tailored this around something that we could kind of do interactive together, but it could be any sort of algorithm. It could be a financial predictor, Bitcoin stock trader, and I'm seeing all this stuff, by the way. Images is one data type. I'm talking with companies who want to do things with audio. They want to be able to tell the tempo of a song when you strip out just the vocals from an audio track. It's not easy to do, and you certainly can't write this program by hand. That's the one thing I'll say. You can actually. They do it. It's called, they use this cascading thing, but you can't do it as quickly as we just did this, and it's not scalable in my opinion. Like you're not going to write a program for every single object in the world, but you could certainly automate this. Create a user interface where people can upload images and then just press go and it can train a model on it. Anyways, neither here nor there. This is a very abstracted approach. Like a lot of the stuff that you guys are still going to see is still like playing with the algorithms themselves and things like that. So we're kind of like leveraging some pre-existing work, but it's just as accurate. Okay, so we have a model. We trained it on data. It seems accurate. So let's push it to a marketplace. So the marketplace that I have is called MacGyver. And what's cool about it is there's no SDK. There's no framework that you have to work within. All you do is you send us your Docker container, and we sync that to our system, and we use that. There are a couple things that you have to set up to work with our platform, which is just basically we have to know where things are in the Docker container. We got to know where you're going to put your files and where you're going to put your data, and it's a standard structure. So you go to the root of the Docker container and you just create a directory called MacGyver. You create a folder called main, and that's why I needed Vim. Main is your executable program, the program that you're actually going to run. And then we're going to create another folder called temp. temp is going to have the dynamic data, the data that is subject to change. In this case, it's the reference to an image, because that image is going to be different every single time a user runs the algorithm against it. So we just want to create a folder to create that. So I'm just going to go in there, oops, I put temp in the wrong directory. So, okay, so we have a folder called MacGyver, we have a subdirectory called temp, and then we're just going to create one more subdirectory called images, which just houses data that is transient. So in this case, it's an image. So we're going to, so in this case, it's just the image data. So we have that set up, and essentially, I can grab a diagram to show you how it works, but I don't know if that's worth it here. Let me just, I don't think it. Well, yeah, let me do that. Just quickly. That's peculiar. I'm going to have caching set up on publish program on MacGyver. Don't fail me now, SEO. Okay, cool. But the actual data, for some reason, let me just double check this. I have some funky things on my local computer here. Why is that pending? That's peculiar. I'm trying to think if I have something set up. So let me just double check one thing real quick before we move on here. So this is the back-end service. It's all built on Google. We work with their architecture, their solutions architecture team. They've kind of helped us build out this application. It can be. We're using Docker. We're using virtual machines. We're using data store. We're using VMs, load balancers, etc. So there's a lot of moving pieces, but they've been very helpful. So I'm just wondering why that's failing, and I'm wondering if maybe I'm on potentially on a VM. Let's see. Why? Okay, I don't know. That's peculiar. Anyways, all right. So this is the setup. To upload a algorithm to our platform, you put everything in a Docker container. Great, we already have that. We did our development in a Docker container. We don't even have to ship or anything. We create a directory called MacGyver. We create a main executable. This is going to be your actual file that runs, and it's just called main, and you don't need a file extension, because guess what? We don't care. Could be Python, could be Bash, could be anything. JavaScript. We create another directory called temp, and in temp is a file called data.json. And what that is when someone's going to want to query against our algorithm, we need the data that we want to analyze, and that's always going to be in a file called data.json. And we can define this right now. Like, how do we want to set this up? Well, we want to set it up as a JSON object, and the only data that we need is an image. So we're going to put in kind of a boilerplate one right there. So let me just grab just an image off the internet here that we can just use kind of as the boilerplate. It's going to get swapped out when someone actually uses this, but just so we have it working here. All right, so this, not confident that's an actual image. Let's try open a new tab. All right, seems legit. All right, cool. So let's try that. All right, so this is what the client's going to send over: a JSON object that has a property called image, and that property, the value, is just going to be a reference to a publicly available image, and then we're going to run our algorithm against that data. So we're just setting up that structure here. So. Cool, looks good. Now our main file we haven't created yet. I thought I created it. Oh, it was empty, so it didn't get written. Our main file needs to piece it all together. And literally, the way I wrote this file was, This is going to be the file that when someone hits our API, we're going to run this file. What does this file need to do? It needs to get data.json, and it needs to run the model against that data. Well, we already did that. Now we just need to piece it together into a succinct file. So really, it just needs to run this. And to be honest, guys, I just grabbed label.image.py and just reworked it a tiny bit. I just added a couple things. I can go over that, but it's actually really straightforward. So I used the file that was shipped natively in the TensorFlow container. All this is doing is grabbing data.json. And it's going to pull out the image from data.json. It's going to write that into our images directory, that transient data that I just mentioned. It's going to call it temp.jpg. Doesn't matter what it calls it. Great. Now we have a local image, and we can run label.py, which is that same command that we ran together where the argument is a reference to an image. It's just this, except it's not done via command line. It's done via Python script. So we're going to write this file. We're going to run this main, and I expect it to run against data.json. What did I get a picture of? A pen. So let's run it. It's a Python file. So we're going to run Python main, and I expect it to predict a pen in the images. All right, couple things here. It says image 1 and image 2. So our labels are not mapped. So let's just do that real quick. What was our first label? Well, let's see. Retrain labels.text. Yep, pen. Good call. So let's go over there, and then let's just, instead of using image 1, image 2, which is not helpful, we will do pen and then USB. Alright, writing this, running it. Where are you? So I expect it to print out, yes, 99.9% that it's a pen. Cool. That's really it. You just got to make sure that this main file does not have a file extension, and you have to make sure that you set up your data.json in the way that you expect to handle it. And in this, you could put a whole host of attributes. You could do like the number of, maybe you could do more than one image. You could do like bulk assessment, or you could do anything you want. But we're just going to keep this simple here. So that's it for making something compatible with our system. That's all you have to do. And this model works, like this approach works for what we've seen, all different types of models. If you want to do an assessment of an audio file, great. Just use the same approach, but instead of image, call it audio, and use a reference to an audio file. Sentiment analysis, call it text, and instead of a reference to a file, actually throw the text in the payload of the request. And again, main is always going to run. The main file is always going to run your model against the data. But we don't care if your model was built with TensorFlow, if your model was built with whatever. We don't even care if it's machine learning. Like, it can do anything. We're agnostic to the framework. We're agnostic to the programming language. So that's kind of one of the cool things about this system here. All right. So we have everything packaged, everything set up. Let's push it to the MacGyver platform. The way we do that is it's less about us and more about the remote registry. We're using the Docker Hub registry. You could use Google registry, and that's what we're going to transfer over to in the future. They're building out for that, which is again is why I say it's a good thing to invest in Docker if you're trying to learn these things, because Google is all about it right now, and Kubernetes as well. So we are going to push this container to Docker Hub, and then we're just going to sync on MacGyver from Docker Hub to MacGyver, and then we should be able to run this program. So I'm actually going to log out. I'm going to log out and get back onto my local machine. That didn't work. Okay, so now I'm back on my local machine. I'm going to do docker list. So that's all my running. I'm going to log out of this shell as well. So these are my containers. The container's still up. It's been up for 43 minutes because we threw that detach flag in there, so we're keeping it up. So the way you turn a container into an image is you commit it to an image. So docker commit, and we're just going to feed it that container ID, which we've been doing all our work in. Everything's there. A container is an instance. A image is a blueprint. So we're now taking that container, which if I stop and delete, it's gone. So we want to commit that to an image. So we're committing that container to an image. I have a Docker Hub account, so that you preface the image name with your account. MacGyver Technology, and then you do /, and then you provide the image name. So what do you guys want to call this? Pen USB detector? Does that work? All right, so the other thing that we do is we use tags to version, because you might come back to this and be like, hey, it's not as accurate as I want. I want to make it better. So you increment the tag each time you want to version it. So this is going to be version 1, so we're going to use tag for 1. This should be fairly quick if we did everything correct. So again, that container, which we've done all our work in, we're just committing it to a new image. Done. Let's list out our images right here. Cool. So let's now push that to Docker Hub. I'm not sure if you guys have used Docker Hub. Again, it's just a remote repository where you store images. We think the Google registry is going to be more prevalent than the Docker Hub one soon. So we're probably going to use that soon. So we have all these images here, but we don't have our newest one, Pen USB detector. So we're going to do Docker push. And then we're gonna supply the image name for the image that we just created. We're gonna put the tag in there, because you can have several tags for one image. And this is gonna push, and hopefully it doesn't take too long. We have a decent connection. I just checked; it's like 6 up. Should be okay. Because you're uploading a VM. So that's one of the VMs are big. They can be a gig, 2 gigs, etc. So let's see here. We're at 15 megabytes. It says 574. Let me think. Let's see. Well, let's see. So it might take. I just need you all to stop using the Wi-Fi. It might take a little too long. I'd really like to show this to you guys. So in the event that this happens, I think I uploaded a very similar model. Yeah. Pen laptop detector. So same thing, but instead of USB, it was a pen. It was a laptop. We can either wait for it to finish. It's going to be kind of slow, or we can use that one that I did last night. Is that okay? Yes. All right, cool. So basically, when this finishes, it's pushing by layer, and each layer is a part of the OS. When this command finishes, it's going to show up in my account here, and I'm MacGyver Technology. That's my account, and here are all my images. So this is one I already uploaded. So okay, why don't we just use this? So if I come in here, pen laptop detector, it has all the different the tags which represent versions. We only have one version here. It's a gig, so these VMs can be pretty big. So good to have a good connection when working with Docker if you're going to be pushing or pulling. But the actual development doesn't depend on that, so shouldn't slow you down there. So I'm actually going to stop this. So we can just imagine we push that to Docker Hub. This should be effectively the same thing. Cool. So we're not affiliated with Docker Hub. Like this isn't. It's a registry. But now we want to pull that onto our system. So I'm going to go over to our website here. Hopefully everything is running correctly here. So this is our client-facing website. I already have an account, so I am just going to search my password here. What was that? Don't screenshot that. Okay, so I'm going to log into my account here. Everything looks good. That's true. So you can add your payment information. One account lets you consume APIs, also lets you publish them. So you can add a bank to set up for disbursements. It's just Stripe on the back end. So your user information here, to use an API, you got to have a key. Public key is something you would use with JavaScript on the front end, where people can see it. And then private key is your back end. So we'll use the private key. If you are going to use the public key, you have to whitelist the origins that you're going to work with. Our website here is automatically whitelisted, so like you could run it from the console here, or you could use our tool, which we have is called Demo, and you could use your public key. But those are your API keys, and then here are different programs. These are some that I've uploaded. They're not all published, just different ones here. But we'll just create a program. We will call it Pen. This is Pen Laptop Detection, and I'm not going to go through all the different kind of attributes of a program here, but I do want to go over a couple things. Which is one is, we defined our input data. We have to put that input data here so when people want to use it, they know what payload to make, like how to present that data to us. It was pretty straightforward. It's just a JSON object with a property called image and a value that references the image that you're looking to analyze. So I'm just going to put that in here. That's just an example. I'm going to save that. Hopefully that runs. I don't know why the back end is being funky. It's really peculiar. It's like, alright, you know what I'm going to do? Let's see here. I don't know why it keeps doing that. Alright. Let me just restart one of the services here. So I'm just going to do... let's restart one of these. Yeah, one of the potential issues of doing things live. So, all right. So I stopped the back end. I'm going to restart it. I'm going to monitor it this time. Well, peculiar. All right, I'm not sure. Sorry. All right, that was a little strange. Let's try that again here. All right, so if this doesn't work, we'll just skip it, but it should be working. I'm not 100% sure. I'll just leave that blank. Should be able to save this. I don't know what's up with that. Anyways, we just got to be able to tell people, like, how are you going to structure the payload data? Because without that, it's just not going to work. Output data, we can just skip over that. The output is going to be the probability that it meets a label. All right, so let's do the actual syncing here. And you can provide all this other information, not relevant here. All right, so the syncing is, we're going to throw the image name in here. The tag is already there. And then we're going to provide the runtime command. In this case, it's a Python script. So Python is the runtime command for Python programs. So let me grab this. So this is the image name, prefaced with my username, / the actual image name. And I'm going to supply that in here. And then we'll put Python here. So we're going to download the image, and then we're going to run Python main. And we're just going to let it do whatever it's going to do, and then spit out the response there. So hopefully this syncs. It's been kind of... it's been a little finicky lately. So what I'm going to do here before doing that is I'm going to start this in the background as a daemon. We have images. I'm going to monitor the images. All right, so this should sync. It's a gig. It's a gig file, and it's going from Docker Hub to the MacGyver system. So it's going to take a second. Google Cloud Platform. The pipes are decent, so hopefully it's quick. Side note: Google Cloud Platform is amazing, and they're super useful. Like they'll just get on a call with you. I've been on calls with them, and it's just like several of their developers, and they're just helpful, which is really cool. So and they take care of back end, they take care of front end, hosting. They'll pretty much take anything off your shoulders if you want them to. All right, it looks like it might have synced. So what I'm going to do here is just double check. I think. All right, so it's not on the system yet, but on the front end here, it looks like it has synced. So while we're waiting, we do need to throw a price on here. This is a whole big thing. Pricing an algorithm is like new territory. So it can be kind of interesting. You probably want to run numbers. If you're building it for someone in particular, you want to see kind of what their volume is. Are they running it over a library of existing files, or do they intend to run it real time in their application? We will add our computation costs on it, so you don't have to worry about that. It does have to have a price though, so we're just going to throw this in here. We have a tool called price calculator, so you can see kind of what the price is over an actual volume of requests. So we're going to throw a price in there. That looks good. We're still not published. We're going to wait. I think this image has not showed up on the system yet. Let me just double check one thing right here. Yeah, it's downloading. Virtual size 1.925. I think that's it right there. It should propagate shortly. Let's give it one more second here. I don't want to publish until it's synced. But what we're doing is it's just downloading the VM from Docker Hub to the Google Cloud platform. And then once it's there, it's there. There's no more syncing that needs to be done. So it is a one-time thing. And even actually, as you increment your program, Docker is really sophisticated. It works in layers, so it should be pretty cheap to sync new versions, because it'll only do the diff of the VMs, which is super cool. But this initial one can take some time. Come on. Yes, it's on the system. 2.5 gigs. Jeez. All right, so the VM is on the system, pen laptop detector. So let's publish, and then let's query it like as if we are someone who wants to use this. So I'm just going to go ahead and click publish here. This will make your program available for public use. Okay. We haven't supplied a lot of info. You'd probably want to supply a lot more info. You might want to say what it does. Anyways, I'm going to take this down later, so it's not a big deal. But this is now published to the system. So if we come over here, a lot of the algorithms aren't published. This I need to take down. I did that 2 hours ago. All right, so this is our algorithm that we just created. No description, that's not good. No output, that's not good. But if I'm a developer, I can kind of see, I post this JSON object, should have an actual image in there, and I can even see, okay, these are some code examples of how it works. Not bad. And here's the pricing structure here, based on the arbitrary price that we picked. And this description could be full, like HTML, rich, whatever. So anyways, so we have it up here. So let's run it against, let's actually run it against some data. So what I'm thinking is we need to get some data to run it against, but we already used Google to find our data. So I searched pens before, so why don't we do sparkling pens? And that shouldn't be the same, I would imagine. So this image is kind of big, so I'm going to pass on that. This one looks decent. So we're going to use this as our kind of like mock data here. And we're going to run our algorithm against this data. But we're going to do it as if I'm not Tim. Like I'm not a user on MacGyver. I just want to run this image against that algorithm. And I'm independent. I'm not logged into anything. I'm just doing my thing on my computer. So you can interface with an API a number of ways. One is using curl. Most people get that. You would never actually do that with programming, so I don't know. But it's useful for kind of like testing the API. So this example here is just how you post JSON to an API. The data that you have to post, we give you a bunch of snippets here. You need to post an ID. The ID is the program ID. When you ping MacGyver, you got to say what program you want to run your data against. You need to provide your API key so we know who you are. We know that you're a registered user, that you have a payment method set up. We need to check all those things. You could optionally provide a version. So like if these models are getting constantly improved, but you're on version 7 and you like version 7, you shouldn't be forced to have to use the latest one. But if you don't, if you omit the version, it will use the latest one.
But you're not doing benchmark for every purchase.
What was that?
You're doing benchmark right now?
Yeah, essentially. We're going to do a single request, yeah.
Did you buy it already or not?
What was that?
It's already bought, I mean. It's already purchased.
No, we just threw a price on it as a publisher. So in order to use this program, I have to abide by this pricing structure. If I query this program 1,000,000 times, at the end of the month, there's going to be a Stripe bill for $3,100. So that's how it works. It happens monthly. 1,000,000 requests is a lot, especially with images. 1,000,000 images is a lot. So, and that was also an arbitrary price. So like I said, like the pricing needs to be more well thought out. But for the sake of this example here, we're just doing one request. If you don't meet a threshold of $5, it's not going to charge you anyway, and you're not going to meet a threshold of $5 when you're doing 1,000th of a penny. So you guys can essentially demo all these APIs for free. It's really when you get into volume that it matters. But what we're going to do is we're going to ping the API with a unique image using curl, and I am going to pass my API key so that it actually registers properly. So if I go to my account, I am going to grab my API key. The private key is the backend key. So I'm just going to stuff it in there. I think that might already be it, but I'm not 100% sure. Yes, it is. We're going to grab the program ID that we want to... where was that? The program ID that we want to query against, which is right here. I don't know why those requests are being finicky, but it's also up here, so we're good. Let's see. Oh, that's not coming through. That's kind of weird. There it is. So that's the program ID. So there's going to be a ton of programs. You have to specify which one you want to use. We're not going to put a version attribute in there because we'll just use the latest version, and we also don't care. All right. Now here's the dynamic part. Our payload data, it's always going to be called data, but we need to abide by what this developer set up for us, which is a JSON object with a single attribute called image that references a file. But, you know, this is that, so we are good on that front. But the one thing that we're going to do is we're going to supply our sparkling pen that we just got here, because we know it hasn't seen this, because we ran it on Google Pens. Well, we don't know, but likely it hasn't seen this. So I'm going to supply that in here. If I could airdrop images to my computer, I would take another picture of the WeWork pen, but I was having trouble with that, so we're just going to skip that. So this is a curl API request. It's not the most elegant thing to look at. We can do JavaScript if you guys want, but most people who work on like Linux systems should know curl. So okay, I'm just on my computer here, local. I have a MacGyver account, which is specified with my private key. So I'm not just a random person. If I'm a random person, I ping this, it'll give me an error. So I provide my key. I'm providing my sparkling pen as my test data, and I'm going to run that algorithm against it and hopefully get back indicator that it's a pen and not a USB cable in this situation here. So hopefully this runs. And we did no performance testing, so I know it took a second there, but it works. And anyone can use it. Like if I gave this code right here to anyone and told you to run it from your terminal, it'll work. And you guys now have a machine learning algorithm at your fingertips. So the idea here is, all these software companies, these potentially small software companies, like in order to compete, they are going to have these rich features, and they're probably not going to have a machine learning specialist to like run the Inception, like TensorFlow, like create a model, but they might be able to come to an API marketplace and be like, oh, nudity detection, oh, not safe for work detection, whatever, oh, tempo detection on audio files, or oh, music graph, and they can just ping an API and be on their way, and they have a really sophisticated feature in their application. And what's also really cool is all these companies that we're working with now, they're trying, like upper management is infatuated with AI, machine learning. They all want to be able to put that stamp in their application. And you could hire a machine learning specialist, and who knows when it gets deployed, and who knows how that works. But you could also just use a third party to do that. Now AI gets thrown around quite a bit. Is this AI? I don't know. It's machine learning. AI, I don't know how intelligent this is. But it's the beginning of a space that is in its infancy. It's growing. You could imagine bots interacting with this API. It doesn't have to be hard coded necessarily. You could imagine a voice interface interacting with this API. We don't care. It doesn't have to be a web application. Could be a device. Anything really. This whole approach is very much in its infancy. It's growing. I will say it's like probably in a place now where it's a bit of a land grab. A lot of these algorithms aren't available. Like simple algorithms aren't publicly available. And yeah, sure, Facebook, Google, all these big titans are, they're not having any issue. They're sitting on tons of data. But how do small companies leverage machine learning? This is one approach. I'm hoping that this is useful to you guys. We are recording it, so we'll throw it on our YouTube channel. One final thing. If you guys are at all interested in this, and you guys are at all interested in, hey, I have a model and I want to upload it to your platform, but I don't really want to learn about the platform, email us. We'll guide you through it. If you don't want to do marketing, we'll help. If you don't want to do sales, we'll help. We're talking with CEOs, we're talking with companies, and a lot of companies, again, really, they hear machine learning, they hear AI, and they just think dollar signs. We can cater to that. I think the underlying math and statistics and calculus and all the kind of what makes up machine learning, I think it's super cool. The first time I saw a machine learning algorithm, it was like the closest thing to like kind of magic. It's really cool. It's incredible. Working in this space is just amazing. Seeing what people are doing with it. But to kind of put an economic machine in place to make all the pieces work, like, great, you're a machine, like, if you're just doing machine learning research and it's not being used by actual companies, well, that's a shame. Like, you can get it out to companies and create an ROI for them and create better consumer applications for end users. Like, end users if a company implements this API, the result is that an end user gets a more sophisticated app. That is good. That's cool. And some disparate machine learning specialist in some country can upload this, and suddenly he's supporting maybe like a widely used application, which is also cool. Anyways, if you guys are at all interested, reach out. We're willing to help. We're willing to sell on your behalf. We're willing to champion you in any way we can. And that's all I got. So thanks.